Okay, this is a continuation of yesterday's stuff, but it's really not that bad. We're kind of barely adding on. On the front side of those notes I gave you, you actually can answer all of this based on what we did yesterday. So I'm going to give you some time, and I want you to work through everything you can on the front page. And I'm going to hit pause on the video, and maybe those people will do that too. Bless you. And then we'll pick up with it here in a second. Okay, some of you guys may not be finished, and that's okay. Let's talk about what you've got, and you can kind of fill some stuff in. I can zoom in. Okay, so did that go any further? Maybe I went too far. I'm trying to match up my computer screen with this screen for video people. That helps. Okay, the position when t is 1, you just take 1 and you plug it into the original equation, and you should have gotten 0. Finding the velocity, you take the first derivative and you get 3t squared minus 6t minus 4. That's from yesterday. Finding the velocity when t is 1, you take 1 and you plug it into the velocity equation you got, and you should have gotten -7. So we're doing okay so far? The acceleration would be the second derivative, so 6t minus 6. And the acceleration of a particle when t is 1, you take a 1 and you plug it into the acceleration equation, and you get 0. Speed, this is from yesterday's notes, remember. Speed is the absolute value of the velocity. Velocity gives you rate and direction. Speed just tells you the rate. So if we get -7 when we plugged in a 1, the speed is 7. And I don't know what the units are, but units per time, whatever that is. Finding the time and position when the particle is furthest left. When I solved the velocity for 0, I found that it changed direction at 2.567 seconds. And then I plugged in a value to the left and a value to the right. It was moving left until this point and then right after that. I didn't include the other route because it says at the very top that time is between 0 and 5 seconds. Kevin?
Did you do the quadratic formula?
I used my calculator.
Oh, okay.
In fact, since I have you guys, and you're not, did your previous teacher teach you about polysmelt? Nope, maybe not. Grab your calculator. Hit apps. These 4 kind of come on your calculator. Does anybody not have one that has polysmelt? Okay, I can give you connectors and I can connect you with that at some point if you want. Yeah, if you don't have it, I've got connectors. I can get that on your calculator. It's not really that big of a deal. Anyway, some of you have polysmelt 1, some of you have polysmelt 2. This polysmelt 1 is probably going to look a little different. Just real quickly, let me just show it to you. It is very user-friendly. If you're looking for a root, you can hit enter, gives you the welcome page, you hit enter. Polynomial root finder, you hit enter. Order, meaning what's the degree that we're looking for. Because we're looking at the velocity equation, it has a degree of 2, so that 2 is blinking already, so I'm good. Do I want it in real numbers or in imaginary? I'm just going to put real. I want it in decimal form because that makes more sense to me. Normal, float, in degrees, not radians is fine. Anyway, I'm going to click this graph button. Do you see where it says next? If I click graph, that's kind of like clicking next. A2, that means what do you want that coefficient to be? Well, if you look at our equation, the coefficient is 3. So I'm going to put a 3. For the next one, it's -6. And for the next, whoops, invalid input. What? Oh, I put -6. Sorry. And then a sub 0, the constant was -4. And then you have all these options down here. I'm just going to click solve. And let me fix the glare. And so it gives me my 2 roots. So I didn't have to graph it. I didn't have to put second calc 2 and got all that mess. The downside is that the polysmelt doesn't give you, like, you can't plug in values and find out what is it when t is 1, what is it when t is 10. You're going to have to use your calculator or maybe your top table or your chart for something like that. And a lot of these you're going to end up having to type in anyway into that graphing thing. So maybe this isn't going to save you time, but if you have it and you're just looking for a root, it's not bad. Yes, sir.
So it should be 2.527.
Yep, I did not copy my first hour answers correctly. Thank you. Good catch. So this is a 2. Thank you. And this is a 2. So anyway, long story short, what I did was is I solved, we found the root, 2.527. Thank you, Tanner. It's moving left until that point, and then it goes right. If we're trying to see when is it the furthest left, well, it's moving left, and then at 2.527 seconds, it zips back to the right. So it's furthest left right at this point. So I just plugged it into the equation, the original equation, the position equation, and got negative 7.128. And that's when it's furthest left. It says to justify your answer, you're supposed to use words. Pictures and diagrams and math numbers kind of help, but words is kind of what we're looking for. There's lots of ways to write up your words on this. I just said that the particle changes direction at when t is 2.527. According to the velocity test, it goes left until 2.527 when x is negative 7.128. So that'd be one way to say that. Find the time and position when it's furthest to the right. Well, if it's headed to the right this whole way, and at the top of our paper it said to cut it off at 5 seconds, it's furthest right at 5 seconds. So when you type it into the position equation, you get 36. And so kind of similar sort of justification on that. It's going to be when t is 5, x is 36. If that makes sense. Like that?
Sure. Can you explain how you determine what points to plug into your calculator to find the x values?
You mean these little guys right here?
Chart you made?
Uh-huh.
How did you?
The 0 and the 5 came from, sorry, I'll put that back, Heather.
You're good.
The 0 and the 5 came from the very, very top. It said that time had to be between 0 and 5. So those are my outermost sort of options. And then the 2.527, which I'm seeing, there's another
You got for t.
correct, is the number I got as the root.
So what if it didn't give you an interval? to go?
Then you wouldn't be able to answer the question, because if it says, like, when is the particle furthest to the right, well, it's going to go on right to infinity, so we don't really know. You see what I'm saying? So they've got to give it an interval if they ask you that question. Good question.
Why is it furthest left 0? Why is it 2
Because at 0, and I know it's hard to see because we always read left to right, but if you think about this, that particle is moving left until this point. So even though like you read this going left to right, if you imagine the particle itself, it's moving left, 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 left until 2.5 seconds or whatever, and then it zips back to the right. So it's at its furthest when like 2.5 seconds have passed. Does that make sense? Yep. But I see where you're coming from. It feels counterintuitive because we always read left to right. It's a little tricky. Anybody else have questions? These are good ones. All right, flip your paper over. We are about to throw a calculus book off of a cliff. Yay! I know you're excited. At the very, very top, and how many of you, just curious, are in physics right now? Some of you, this is going to make a whole lot of sense to you, and you probably already know how to do a bunch of this. Now, granted, physics people, don't come up here with a baseball bat or anything and be all angry, because I understand this is what's happening without wind and air resistance. So it's not reality. I get that. But we're just going to, this is a good starting place for us mathematically. When we're talking about throwing an object into the air or off of a cliff or I don't know, catapulting somebody through the sky or whatever. These are the equations you're going to use. The top one is in feet, so we're talking about like standard sort of customary units. And then the other ones are in metric. So if you're talking about meters, this is the one you use down there for that. Yes, please memorize these. V sub 0, don't be afraid of that funky looking thing. It just means the initial velocity, which they will usually give you or make you find it. Y sub 0 is the initial position. That's what you start from. So let's dig into the problem. Chuck stands atop a cliff and throws his calculus book into the air with an initial velocity of 20 meters per second. And I know you're wishing you're Chuck right now, standing on the edge. It says to write a function for the height of the book. Are we in feet or meters? Meters, it says. So we're going to use the bottom equation. So we say h at t is negative 4.9 t squared plus initial velocity times t. They gave us initial velocity and it was 20. So 20 t. Okay, now for the initial position. All kids fall into one of two camps. You're either that guy that looks at Chuck standing on the edge and you're like, okay, I'm going to call where he's standing is 0. And then that calculus book gets thrown off the cliff. You could be that guy. So you would put a +0 over here. And I'm going to kind of make it dotted because you don't have to put it. You might be that kid who kind of quickly reads down through here and you see that later on that cliff is 160 meters above the ground. So you might say that Chuck is standing 160 meters. And so you might call that +160. Either way, we're all going to wind up with all the same answers. It doesn't matter. Whatever makes more sense to you. I'm going to put the +0 because that's what I've already got there. But it doesn't matter. How many seconds does it take for the book to return to Chuck's position on the cliff? So in other words, starting at 0, how long until it comes back to 0? Or if you called this 160, you're going to set the equation equal to 160. I'm going to set mine equal to 0 because I called Chuck's position 0. If you called Chuck's position 160, you're going to set it equal to 160.
Well, either way, once you're setting it equal.
Either way,
to 0.
you wind up getting this equation. Because if you have a 160 over on the right and a 160 on the left, and you subtract 160 from both sides, poof, it looks just like the one I just wrote. So it doesn't matter.
And we're solving for t.
Correct. Now, obviously, this is one of those things that you're not going to want to try to factor. So we grab our calculators. And because so many of you don't have that poly smelt, we'll just all type it in together. We type in -4.9 x squared plus 20x. And we can graph this thing. I'm going to hit zoom 6 to kind of see where it's going to start out, and then I can adjust my window. I'd love to see the top of that parabola, so I'm going to hit window. I want it to be taller, so I go to Y max, and I'm going to put, I don't know, 50, and I'm going to go up by 5s. So for my Y max, I'm going to put 50. See if that doesn't help a little bit. Yeah, that's pretty good. So it's giving you the trajectory of the calculus book. We set the equation equal to 0. How am I going to find at what point it hits that place again? Where Chuck is standing. What do I do? Yeah, it's where it crosses the x-axis. Because here's Chuck, at time 0, it's at 0. Throws the calculus book, and at time 1, 2, 3, it looks like it's going to be about 4. It ends up even with Chuck again. So, second, calc 2. I don't care about the first root. I know that's 0, 0. So we move our cursor so it's just to the left of the root on the right and hit enter. Move the cursor so it's just to the right of the root. Hit enter. Hit enter again. And it tells us that it's 4.082. 4.082 seconds. So after 4 seconds, he must have really threw that thing hard, went really high, came back to about where he is.
Can you go back to the calculator problem?
Say again?
Like, can you go back and get a calculator?
Uh-huh. So if I want to know this root right here,
Or, like, how did you get there from the last thing we were at?
did you type the equation in? Okay.
So after you...
You type in your equation.
So you didn't need to put it into the poly thing?
No, huh?
Okay.
I didn't do the poly smelt just because so many of you guys don't have it.
I don't need to.
Okay, great. Now it says for how many seconds is the book 15 meters or more above Chuck's position on the cliff? Let's think about this. Chuck throws the book. Let's call this 15 meters above where he's standing. Now, if you were that person that you called where he's standing 160, then you're thinking the number 175 because that's an extra 15 meters. Does that make sense? So if I want to know how much time passes before between when the book is this place to when it hits this place again, I need to know when it hits those places. So we're going to set the equation equal to 15. Have you guys noticed so far this whole problem has nothing to do with calculus? It's all algebra so far. This is all stuff you've already known how to do. So we have negative 4.9 t squared plus 20t. Again, if you're that kid that you had a plus 160 over here, then you're going to set yours equal to 175. Let's subtract from both sides. And it's at this point that we all now have the same equation. Okay, how am I going to find what t is? Type it in, find the roots, right? So go to your y equals button, leave the same equation in there, and just put minus 15 at the end. And if you graph it with the window that we have, you'll see that it's a little bitty arc, and if that really bugs you, you can change it. We can go back to our window and we can make this this y maximum like 15 or something. There we go. And I want to find both roots this time. So we hit second, calc 2. I'm going to pick the root on the left. So I'm going to put my cursor just to the left of that root and hit enter. Move my cursor just to the right hand side of the root and hit enter. Hit enter again. And I get 0.99. So the first time that book hits that place is at 0.99 seconds. Let's find the second one. Second, calc 2. Put the cursor just to the left-hand side of that second root, hit enter. Move the cursor just to the right-hand side of the root, hit enter. Hit enter again. And it's 3.09. We'll just stop there. 3.09 seconds. Yes, sir.
If you did set it equal to 175, whenever you subtract 175 or set it equal to 0, then at the end of that equation, if you have minus 175.
Yeah, what would be over here? It would say 160 minus 175, which is negative 15. If you put 175 over here, you had to be that kid that called that 160. You see what I'm saying? Good question. So what our answer is, what's happening here is that at almost a full second, it hits this place above Chuck's head. And then at about 3 seconds, it hits that place again before it comes back down and goes into the abyss. So how am I going to know how much time has passed between those two times? Yeah, you just subtract. So 3.09 minus 0.99, and we get 2.1. So 2.1 seconds have passed. Questions so far? Number 3. If the cliff top is 160 meters above the ground, how long does it take before the book hits the ground at the foot of the cliff? Again, this is not a calculus problem. We're still doing algebra. This cliff is 160 meters to the ground. So, if you were like me and you called Chuck's position 0, I want that book to hit negative 160. Does everybody see what I'm talking about? So I'm going to set my equation equal to negative 160. If you are that other kid that you called Chuck's position 160, then you're wanting that book to hit 0. So you're going to set it equal to 0. Either way, once we all finish kind of writing, our equations should match exactly. So it doesn't matter. Find your roots. So we type it into our calculators. You're going to want to fix your window because it looks really, really crazy. I'm going to make my Y max 200 and my scale 20. So you can see the whole graph. There are 2 roots. I don't care about the one on the left because we cannot go back in time. Negative 4 seconds does not help me. But over here is where it hits the ground. So I'm going to hit second, calc 2. I'm going to put my cursor just to the left of that root. and hit enter. Cursor just to the right of the root, hit enter. Enter again, and it's 8.11. So it takes 8 seconds for that thing to hit the ground. Questions so far? All right, what's the speed of the calculus book when it hits the ground? Now our calculus starts. Speed, when I see speed, I'm thinking kind of velocity, probably has something to do with that. So let's find the equation for velocity. So we take the derivative of our initial equation, and we get negative 9.8t plus 20. There's the equation, but it says, what is the speed when it hits the ground? When does it hit the ground? 8.11 seconds. What do I do with that? Plug it in. Good. And the answer is negative 59.5, right? Why not? Absolute value. Speed is always positive. So the answer is 59.5 meters per second. Good job. Last one. When does the calculus book reach its maximum height? Now think about this. I mean, yes, you have a calculator that will do it for you, but here's what I really want you to think about. Or you have a calculator. Did I say calculus book? I meant calculator. The calculus book, if you throw that thing, it hits this highest peak and then it goes back down. It's changing direction. What equation talks about direction? Velocity. So you can take your equation for velocity and set it equal to 0. So it's asking, and this is my notes, so I'm going to go ahead and write the word turning point. It wants the turning point. It wants to know, when is the calculus book at rest? That word's going to pop up on your assignment today. It means, when is the velocity 0? Because there is no speed when it's at rest. So we say 0 equals negative 9.8t plus 20. Solve for t, and we should get 2.04 seconds. That calculus book is the highest it's going to get at about 2 seconds. Questions? Are we okay? They're really not that bad. All right, let me hit stop.